Greek donut. Sundial? Yeah, sundial.
Surfaces are controlled action of the sun's turbulent surface.
The ATST will look like a nighttime telescope. It will have a diameter of 4 meters. And with that size of aperture, you can saw all of the
Yeah, sorry to have missed you this morning.
spectrality, the temperature, discovered the origins of the solar cycle, causes of the variable brightness of the sun, and the origins of explosive flare events on the sun that can affect human activities on the Earth and also in the near-Earth space environment.
But the sunspot cycle reveals just one aspect of the great mystery of the sun's magnetic environment, free from atmospheric interference. Each scene exposes the tapestry of the universe, the dynamic interplay of matter and energy that paints our human.
What's your weight? May bayad. May bayad. Picnic time. It is 5:07. So probably 30-40 minutes. Wait.
I get accused of that as well, by the way. I do. Oh, that's better. Yeah. And so, because of our small aperture, we're not able to collect that much light to see that far out, right? The telescope. Okay, Laura, I've got 4 more people, and we're going to be down there shortly.
I'm going to be your guide tonight, along with Darcy. Everybody say hi, Darcy. And Kathy. Everybody say hi, Kathy. Hi, Kathy. Specifically, those of you with the red lanyards, I'm going to be your guide tonight. Those of you without red lanyards, Kathy and Darcy are taking care of you. We've got Mount Lemmon to the north, Mount Graham to the east, Mount Hopkins to the south, and Kitt Peak to the west. We've got telescopes for every cardinal direction. And if you notice a pattern, all of these telescopes are on mountains.
Measurements are perfect. And then they put it into the telescope and they make their little precise measurements. And once it's all done, then they convert that exact pattern to the real mirror. Let's move over here. I want to tell you, for those of you who are locals to Tucson, if you go to Gates Pass and you look through the gazebo, you can see this on top of the mountain. So you can see it from 50 miles away. But what is it doing, right? What's it even looking at? It's studying dark energy. Does anyone know what dark energy is? Well, it doesn't shine. It doesn't shine. But if you did know, that would be concerning because you'd have a Nobel Prize coming your way. And you should probably be up in that telescope.
Ito na yung hike.
that immense pressure and gravity are getting collided together. And in that collision, thermonuclear fusion is happening. So when those helium atoms combine, they make a helium atom. And in that interaction, a little bit of energy is released. And that energy is released in the form of a photon. Now that photon, when it
I'm sure, yeah.
So, gantay kami. Gantay namin si ate.
Oh, yeah. Now it's NOIRLab National Geographic. Yes, I've seen that. But we went down there. They have a, well, I don't know what they had. When we went, they had like a
Oh, wow.
16-day trip.
Yeah, in fact, most of the telescopes that are remotely operated.
You just fly to Argentina. You go for a day.
And we thought, oh, we want to do an article.
Okay, we're going to go, well, what we do is,
So it is a clear day, so we might be able to see it. It'll just be a moment of a little green blip.
Remember, it takes 8 minutes for it takes 8 minutes for the sunshine to get here, so when it's dipping down, it's already down below the horizon.
yeah.
So
And the thing I liked about
we're so close now. I like how the dip is lined right as it goes down, right on the edge. It's beautiful. There's some amazing sunsets.
Oh, yay, awesome. Thank you,
No, you see the green?
John. Anyone see it?
no.
No, I saw like a
It's hard to see. I didn't
halo
see it
edge
either.
that I thought
Yeah, I didn't see it.
green, but I think that's okay, Kathy.
We're going to talk to her.
Do you want us to rewind it for you?
Yes, please.
We had a little game like
All right, so we just got.
I was a little disappointed to work through the Arctic because I mean, it's so cold.
Stop moving.
So this we want Antarctica. Yeah, you between the penguins
Ang ingay po nila. Yung mga kasama namin. Joke lang.
Creating the first 3D map of the universe. So if you guys go home and just Google like DESI project, DESI, and then 3D map, you can see actually the map that it's creating. So each dot in that map is a galaxy. Yeah, and they have them color coordinated too, so that the red galaxies are like the galaxies furthest away from us, and you can actually kind of fly through them in their 3D map.
If we have the lanyards, are we supposed to go in there?
So do we. When we went to
I like it because
a year ago,
Oh, yeah, I mean, that's what the natural habitat is.
yeah, so there were things to wear if it was very, very good.
We just did, had it going in, 2 years ago. So, same thing.
Hinikutan ng mata. Joke lang.
I mean, we loved it.
I love that. I love that.
It's actually the shadow of the Earth. So wherever you are, whenever you can see a sunset, if you can look the opposite direction, you can actually see the shadow of the Earth. And you'll notice if you look off this way, that the shadow dissipates. And then if you look the other way, it dissipates as well. That pink band is called, has two names. Its nickname is the Belt of Venus, or it's also called anti-twilight. And what it is how big it is. You see that bird hold? That's 100 feet tall. The diagonal is 200 feet. And then on that same line, it extends underground for another 300 feet. Yeah, it's massive. So at the top, there's a component up there. It's called a heliostat, which just means it's like a slew of mirrors. There's 3 of them. So sunlight comes, it hits those mirrors, and it travels down that diagonal piece, and it travels down. So an exoplanet is a planet that is orbiting a star that's not our own. So there's a couple of different ways that you can detect an exoplanet. There is one where you're looking at a star and you're noting the brightness of it. Now, when a planet goes in front of that star, the brightness dims just a little bit. And when I say just a little bit, here's kind of actually our original visitor center back in the 60s. And this observatory's claim to fame is pretty cool. So back in the 60s, an astronomer named Vera Rubin made some pretty important discoveries on this telescope. She was obsessed with galaxies. And she noticed some interesting things. So she would study them, and she really liked M31, the Andromeda galaxy, the closest galaxy to us. And what she did was she was looking, and she noticed that the stars in the center of the galaxy were moving at the same rate as the stars on the outside. Now, if you can imagine yourself on a merry-go-round, and someone is spinning it really, really fast, and you're standing in the middle, you're going to be okay. But the further out to the edge that you walk, eventually you're just going to get flung off. So when Vera Rubin was looking at these galaxies and these stars weren't flying away, she thought, wow, that is really strange. What is going on here? She correctly discovered dark matter. So dark matter is different than dark energy. So dark energy, what DESI is doing is the stuff between the galaxies. And then dark matter is what makes up most of the matter in the universe, and it's what holds the galaxy together. So we talked about DESI and its dark energy. When we follow it down to the left, you can see there's 3 more observatories. You might only be able to see far away. Now, lucky for us, we have Jupiter, because Jupiter acts like the protector of our solar system. And what it does is when we have these smaller bodies coming towards it, its huge gravitational well will kind of bring it in close, and then it will rip it apart. And that is exactly what happened with Comet Shoemaker 11-9, is this comet was coming our way towards our solar system, and it just ripped it apart, and it kind of absorbed it. And it actually had what looked like these bruises along its side. Yeah.
And just walk, just not in the first row, okay? Not in the first row. That's the splash zone. That's who I ask all the questions to, so.
I send them out,
She's like, okay, I'll in the back.
just like in college.
And all it is a star map of the evening sky. That's it. They're a little different than, quote, star maps that you find in the magazines or those that you can print online, because those only work for a certain time of the year and only during a certain part of the night. So if you print out one of these or find them in a magazine, it'll say good between March and April from 8 to 10 p.m. Right? And that's it. These work all year round. So I'm not going to, if they're both visible, I will show you how to do it with both of them. Okay? So the two constellations that we're going to look at, one is right here. It's called the Big Dipper or Ursa Major. And it looks like a spoon, right, with the handle right here. Everybody find it? Mm-hmm. You should see that it says Ursa Major on it. The other one we're going to use is directly across. Just put my cheaters on. It's going to be this one right here. It's called Cassiopeia. It looks like a 3 or an M or a W, right? You see it? Yeah, right there. Okay, I don't want you to do it, but as you spin the planisphere, you'll see that all the stars go around the rivet, right? Because that's what actually happens, right? As the Earth turns, they all go around that one center star, which is our North Star, right? And so you can see how you're able to use this all year round. So we're going to be using that. Now, from the center of that rivet, where Polaris is, you're going to notice some lines coming out of it, right? Mm-hmm. Splits the window like a pie or a pizza. Look on any one of those lines. You're going to see little tick marks. Some of those tick marks have numbers. What numbers do you see? Degrees, right? In increments of how many? 10. Does everybody see that? Right? 50, 60, 30, right? Okay. We're going to show you how to measure the sky. Because the whole goal is to go out there and go, oh, there's that constellation, there's that constellation, there's that constellation. But if you don't know what you're looking at, this planisphere has a dotted line with an arrow pointing to the rivet. Does everybody see that line? I want to make sure that you guys see it. Do you see it? So if you look where the Big Dipper is, right, you're going to use the two stars here. See the dotted line that points to the rivet? Right. Okay, now, if we can see the Big Dipper, I'm going to show you the hand sign. Now, count how many tick marks from where the line starts, that dotted line starts, to Polaris. How many degrees is it away? 30? I get 28. Some people tell me, it's not quite 30, but yeah, it's okay. It's roughly there. All right, so to measure 25 degrees in the sky, this is a shortcut, so it's not going to get you all the way there, but it'll get you close enough. 25 degrees, you hold out your arm like this, straight line, and you hold up the letter Y, count on, hang loose, What I do is I point my wrist forward as you look down the barrel of your arm, and you're going to do this out there. I'm going to tell you to do this. If you point your wrist forward, then you can see, if you twist your wrist a little bit from the tip of your thumb to the tip of your pinky, you can imagine a straight line. So that line is going to represent the dotted line on your planisphere. So we're going to, and it works if you do this or this, it doesn't matter. I'm going to say, put your thumb or your pinky right there on that star. And we're going to use the bottom star to make a straight line. Triangle is taller, the other triangle is shorter. Just keep that image in mind, because when we go outside, we're going to use the big or the small triangle to star hop our way around as well. But if you take that center star and then the top of the small triangle, kind of imagine a line, it's not a straight line, eye, and then use the knob to focus on your left eye only. Once you get a nice crisp image, you're gonna close your left eye, open your right eye, and try this here too. The right eye, if you use these two fingers, your eyepiece twists. You have to twist it very far. And again, don't focus on anything in here because you're just gonna have a harder time out there. I just want you to change position, but now it's in a different location. Do you see that? Cassiopeia is right here.
Okay.
It should be
Yeah.
facing. I want you guys to get this so you can see how when you're looking in different parts of the sky, where the things are. Because as you're facing north, it was in one direction. Now that you're facing here, you see that it's over to the left a little. Yeah? Okay. Do you see it now? All right. Now we did north. We face east. Now what we're going to do is look south. And you want to get away right at the heart of the
Scorpius
scorpion is a big blue dot. What is the name of that dot? Antares. Yeah. Anti-Aries, anti-Mars. Go ahead and shut off your planisphere to see how bright it is. Now you can see that big blue dot.
Polaris. Triangle. Cassiopeia. It's facing north. South facing. We got Scorpio.
So we just put his telescope in here 2 weeks ago, and as you can see, it's pushing the limits of how big a telescope can be in this observatory. So this is a 20-inch telescope. I'm sure Kathy told you about the 16-inch in the dome. This one's a little bit bigger, and you remember that? It's right here. So you guys are going to be seeing two bright stars. Do you see kind of one that's blue and one that's warmer?
Yeah.
It's kind of an orangey color.
Yeah, I think so, yeah.
Exactly. Also, I don't think you see, but if you guys have a hat, like turn it on backwards, or just lift it up every time. And then, remember how Kathy said use your averted vision on these things? When you guys come up, use your averted vision, and you'll see that that double turns into exactly what I'm saying. 2 stars, but each of the 2 stars, if you look carefully, are 2 stars and 2 stars. Take a look. There's an eyepiece. It might be slightly distorted. So, globular clusters. We are actually looking at an object outside of our Milky Way galaxy. And in fact, we have 150, or around 150 of these that are orbiting our Milky Way galaxy and its galactic halo. And they contain some of the old stars that astronomers know. So these are ancient stars. So stars kind of come in generations. Star in its end state, so its final state. So this star has died. spiral galaxies, and spiral galaxies are like Andromeda, and they're like our own Milky Way galaxy. And spiral galaxies are actually the galaxies that have star formation. So not every galaxy is forming stars. Spiral galaxies do. The other type of galaxy, there's a couple of them. There is elliptical galaxies, and they are just kind of a cigar-shaped galaxies. A lot of its moons. Another one, if you look along the plane of the rings, you can see a lot of galaxies. Count how many. It's cool. There's frozen magma, but the crust on Saturn is frozen ice, and below it there's a liquid ocean, so almost salt. Salt ocean.
Very good. Start walking down.
I think it's just the one that didn't see me. It didn't
We're back. The visitor center. Good.
Those of you that were in my group, again, remember Darcy and I are gonna upload those pictures that we took. You guys have your own souvenirs on your phone as well. We are going to leave in a few minutes here. It is okay for you to turn on your white flashlight from your cell phone to see where you're going. So long as, when you see the light go like this, that's to start your engines. Everybody turn on their cars, lights come on at the same time, that's great. Lorelai's gonna tell us we're gonna be able to leave. As soon as the van starts heading down the hill, you're free to follow. Any questions? Remember, Lorelai's gonna pull off to the side, you don't follow, you keep going. All right?
Okay.
Watch for the animals, make it home safe.
Thank you.
Thank you guys for coming.
Have a good night, guys.
So we're walking back to our cars.